Okay. Okay, so I'm going to do a specific example of solving a linear combination of cosine and sine equal to a number in a specific domain, just like you've done on the back side of your homework tonight, and you will do tomorrow. This problem doesn't require use of a calculator, so we should be able to get all the answers algebraically. Though you know the little calculator symbol means that you'll need to use a calculator to find the answer for some of them. Okay, so step one is to turn the left-hand side into a single cosine. So if I remember, the formula says that the constant in the vertical dilation is the square root of the sum of the squares. So if I square, this is my A and this is my B. So squaring negative root 2, this we get square root of negative root 2 squared plus root 6 squared, all under a square root. Simplifying this down, this is 2 plus 6 square root of that. So this is the square root of 8. Which can be written as 2 square root 2. So that gives me the vertical dilation factor. And so it remains to figure out what is the phase shift on what is the phase shift on cosine. And to find the phase shift, that uses the inverse tangent. So d is equal to tan inverse of root 6 over negative root 2, which is equal to the tan inverse of 6 divided by 2, which is 3. So this is negative square root 3. And this is a particular there's an angle that we know where the tangent is equal to negative root 3. So I'm going to draw a picture over here to show what that angle is, or the possibilities for that angle. So the tangent is equal to negative square root 3 at this angle and at this angle. And this one is 2 pi over 3, and this one is negative pi over 3. And so we have to figure out which answer we want. If we want the answer in quadrant 4, or if we want the answer in quadrant 2. Well, if you remember looking back at this original equation, we know the cosine is negative and the sine is positive. So which quadrant should that end up being in? We want the cosine to be negative and the sine to be positive. That one is in quadrant 2. Quadrant 2. So that means that D is in quadrant 2. So that says then that this angle is not the negative pi over 3 one, which is the one your calculator would give you, but instead the one that's pi away, pi past negative pi over 3, which is 2/3 of pi. So D is equal to 2 pi over 3. 2 pi over 3. Okay, I'm going to erase this. Before I carry on solving this equation, x equals root 2. Before I carry on solving this equation, I'm going to just use the angle difference identity on this cosine to show that it is in fact equal to what I started with. So, check. Using the angle difference identity on cosine. So this is equal to 2 square root 2 cosine x cosine 2 pi over 3 plus, put parentheses around it, sine of x sine of 2 pi over 3. Okay. And cosine of 2 pi over 3, this angle right here, this is equal to negative 1/2, and this one is root 3 over 2 up here. So this is negative 1/2, and this is root 3 over 2 sine of x, cosine of x, 2 square root 2 all in front of that. And I can distribute my 2 root 2 to both things, so that's going to give me negative 2 root 2 over 2 cosine x, and then plus 2 root 2 times root 3 over 2 sine of x. And if I simplify these, 2's cancel here, 2's cancel here, I get what I started with, negative root 2 cos x, and this one's root 6 sine x as desired. That's what I began with. So that's good. Oh, forgot the x. Okay, so now that we double checked that this is in fact the single cosine that we're interested in, we put D in the correct quadrant. I'm going to go ahead and solve this for x. And we're interested in solving the x that's between, solving for x is between 0 and 2 pi. Okay, so now it's just as simple as undoing all the things being done to x. So the first thing we need to do is divide by 2 root 2. To cancel that multiplier, cosine x minus 2 pi over 3 equals root 2 divided by 2 root 2 is just 1/2, because these cancel, root 2's cancel. And now I inverse cosine, and I say, well, cosine is equal to 1, so we can do the inverse cosine of both sides. Inverse cosine. And then it says x minus 2 pi over 3 equals, when is the cosine equal to 1/2? I'm going to draw a different picture for that one. Cosine is equal to 1/2, so my x coordinate is 1/2. So we've got two angles to look at, one that's pi over 3 and one that's negative pi over 3. So it means we have plus or minus pi over 3 plus any multiple of 2 pi. Those are all of the solutions. And then we are going to lastly add 2 pi over 3 to both sets of numbers. So let's finish that out. So we get x equals pi over 3 plus 2 pi over 3 plus 2 pi n, and then or negative pi over 3 plus 2 pi over 3 plus 2 pi n. So what are these sets of numbers? This first one, 1/3 plus 2/3 is 1 whole, so we get pi plus 2 pi n. And then negative 1/3 plus 2/3 is positive 1/3 pi over 3 plus 2 pi n. So the numbers that are between 0 and 2 pi, if we plug in various n's, we can plug 0 in, and that gives us pi, and 0 into this one, that gives us pi over 3. We have pi over 3 and pi. If I plug 1 in, that's going to get me to 3 pi, that's outside my domain. If I plug 1 in here, that's going to give me 2 pi plus a pi over 3, that's outside the domain. If I were to plug negative 1 in, that's outside the domain. Negative 1 in, that's outside the domain. So these are the only numbers between 0 and 2 pi that solve this equation that are solutions. Cool.